Hey guys, welcome to Unit 3. This is going to be day 1, and we are talking about triangles. And we have a warm-up, and it says that ray RT bisects angle QRS. So we're going to go ahead and start with an angle. And we'll call it QRS. And then we're going to have a ray RT cut that angle in half. And remember, when an angle gets cut in half, we get two equal angles, and we use arc marks to mark it. Okay, and then it tells us angle QRS. QRS, now that's the whole angle. You guys know I like to use a bracket to represent the whole angle, and that's going to be 10x. We also have angle SRT. Oh, I forgot the label. I don't have a T in my picture. This has to be T out here on my rays to be ray RT. Okay, now I can go back and say angle SRT is 3x plus 30. And they want to know the measure of angle QRS, which is the whole thing. So we'll plug into the 10x when we're finished. Okay, so first off, what we have to realize is that there's no way 3x plus 30 can equal a 10x. 3x plus 30 is only half of the angle. 10x is the whole thing. So a couple things we could do is we could say it takes two halves to make a whole, or we could go ahead and borrow that 3x plus 30, and we could put it up here and realize part plus part equals whole. It does not matter to me how you think of it. I like to put the 2 and then the half and equal it to the whole. But it's also okay if you do 3x plus 30 plus 3x plus 30 equals 10x. You get the same thing. Here you have to distribute, whereas if you did it the other way, you just have to combine your like terms. Okay? And this will give you a 6x. 2 times 30 is 60, equal to a 10x. We're going to go ahead and subtract 6x. And we end up with a 60 is equal to 4x. Divide by 4, and x is going to come out to equal 15. Okay, that's not the question. They want to know what the measure of angle QRS is. QRS is the whole thing, or the 10x, and so 10 times 15 is equal to 150 degrees. And if you think about it, that angle would be classified as obtuse if they asked. Okay, but that's all they wanted. Okay, good. All right, going down, we got to talk about a polygon. A polygon is a closed figure. Poly refers to many, gon refers to sides, so it's many sides. It could be as many as you want. If it's 3, because that's the smallest amount of sides you can have for a shape, you can't have a shape with 2 sides. If it has 3 sides, then it's called a triangle. 4 sides is called a quadrilateral. 5 sides is called a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. Okay, and so on and so on. So the line segments are the sides of the polygon, and the endpoints are the vertices, also known as a vertex. Vertices is plural. A polygon is named by the letters of its vertices, starting with any vertex and going in order in either direction. So if we had a triangle named ABC, he would be known as triangle ABC. Okay. If we had a quadrilateral called PQRS, this would be quadrilateral PQRS. Okay, and so on. So a triangle is a closed figure formed by 3 line segments. A vertex is a point where 2 sides of the triangle meet. This is an important one. We talked about this in the last packet. The sum of the measures of the interior angles is 180 degrees. So in our triangle, if we had 3 angles, angle 1 plus angle 2 plus angle 3 equals 180. Can't have 2 angles add up to 180. It's got to be all 3 of them. The largest side is always across from the largest angle. So for instance, if you think about an obtuse triangle, this would be the largest angle, therefore this would be the largest side. It's across from it. Okay. And likewise, the shortest side is always across from the smallest angle. Triangles can be classified according to their sides and or their angles. So we'll actually have 6 classifications, 3 by the sides and 3 by the angles when we're finished. Okay. We're going to start off with the sides. First one up is scalene. Okay. S for sides, S for scalene. Scalene is a triangle with no congruent sides, and therefore no angles are equal either. Okay. Let's say we have a triangle. Let me just fix my triangle. There we go. And in our triangle, let's say that we have a 50-degree angle, a 30-degree angle, and 50 and 30 make 80, so there's 100 degrees left for this angle up here. So that's no equal angles. It would also have no equal sides. And across from the 30-degree angle, let's say he's the smallest angle, we're going to make this our smallest side of 8. This is the medium angle at 50, so across will be the medium side of, let's say, 9. And across from the 100-degree angle will be our largest side because our 100 is our largest angle, and let's say it's 10. So this would be a good scalene triangle. No sides are equal, and therefore no angles are equal. Okay, so that's a good scalene triangle. All right, the next one is called isosceles. And I always think about isosceles, just like you have how many eyes on your face. And they should hopefully be the same size. Therefore, hopefully my little drawing reminds you that isosceles triangles are 2 congruent sides. Like you have 2 congruent eyes on your face, isosceles. This triangle we're going to be spending a lot of time on. He has the most amount of stuff going on. He can get pretty fancy. So we have isosceles triangle, and I'm going to make these my 2 congruent sides. Hence, I put tick marks on them because tick marks show that those lengths are the same. And the 2 equal sides are actually called legs, which I think is funny because we also have 2 legs, and hopefully our legs are also the same size or the same length, just like an isosceles triangle's legs are. Okay. The third side is actually called the base, and the base word can get misleading because the base doesn't always necessarily have to go on the bottom, because if you think about it, I could turn this triangle whichever way I want. The base could be up in the air, but the third side is called the base. The angles opposite the equal sides are called base angles. And they are equal. So across from one leg, if you kind of go across, you get to this angle. If you go across from the other leg, you get to this angle. And this angle is called the base angle. And so is this one. Notice that the base angles are on the base, or some people will say that they're across from the equal sides or the equal legs. Okay. The third angle is called the vertex angle. So up here, this is called the vertex angle. Okay. And it's always included. Included means between. It's included between the equal sides. It's between the equal sides. Okay. All right. Last triangle we're going to talk about with sides on this page It's called the equilateral. Lateral, that word in there refers to side, and equal refers to equal. So it's a triangle with 3 congruent sides. Since he has 3 congruent sides, you're going to see that his 3 sides will have tick marks on it. And because he has 3 equal sides, it will also have 3 equal angles, which is known as equiangular. Okay. And since triangles only have 180 degrees, if it has 3 equal angles indicated by the arc marks, there's only one way to split 180 degrees 3 ways, and that's to get 60 degrees for each angle. So this one's 60, this one's 60, and this one's 60. Okay. We could also fill in the angles on the isosceles. I didn't do that, but we could if we wanted to. For instance, on the equal angles, we could make them both 70. And therefore, there would be 40 degrees left for the vertex angle. All right, so that's our triangles. We have S for sides, S for scalene, isosceles, look at all those S's in there. So it's a side classification. And we have equilateral. Lateral refers to side. Okay. All right, so those are our classifications based on sides, and then we're going to do angles on the next side. Okay, I'll see you guys there in a second.